see how much crazy stuff we can say today while I'm recording. I want to keep that in the corner to remind myself that we're recording. Try not to fly off the rails today. Okay, this was very similar to one that we did in class and one that was on the review thing that you did. But you have to be able to write the equations. And so a lot of people didn't get a lot of points on this, but this is where I think you can come back and retake this. And even if you miss all the multiple choice, you can get 6 points on your FRQ. And hopefully you don't miss all the multiple choice the second time around. So it tells us the ladder is leaning against the house. When the base starts to slide away, by the time the base is 12 feet from the house, the base is moving at a rate of 5 feet per second. I called this X, I called this one Y, and if I'm relating the sides of it, I have to use Pythagorean theorem. So many of you used area maybe? I don't know. Maybe I need to look at it and look at your area formula, but Pythagorean theorem is what you should be doing here. So you should have said x squared plus y squared equals 13 squared, because 13 is a constant, it's not changing. And if you wrote that, you got a point. And then the second point comes from taking the derivative with respect to time. And if you didn't put that in as a constant, then you now have too many variables. You don't have enough stuff to solve. So then you would say 2x dx over dt plus 2y dy over dt, and the derivative of 169, which is what the derivative 13 squared is 0. We don't need a rate of change because its derivative is 0. That was worth a point. That was worth a point. And then the third point comes from actually plugging in the values correctly and solving it. We know, but the time the base is 12 feet from the house. So at this moment, we know x is 12. We know the base is moving, so we know dx over dt is moving at 5 feet per second. This would be 12 feet. What we're trying to find is the rate that this part is moving. So we're trying to find dy over dt. We don't have y, but we can do Pythagorean theorem. And if you do Pythagorean theorem, I think that you get 5. Because 5, 12, 13 is a Pythagorean triple, or you could just do Pythagorean theorem to get that. And so when you plug all that in, you get 2 times 12 times 5 plus 2 times 5 dy over dt equals 0. And if you solve that, you can subtract that over, and it's negative 120 over 10, which gives you negative 12 feet per second. And it should be negative because it's falling just like the ones that we did, negative 12 feet per second. That was the third point. If you retake this, it's going to be the same type of problem, just the numbers are going to be different. These worked out really nice. I can't promise that the retake's going to work out as nice, but you get a calculator, so even if it's a decimal, you can give me the decimal. There's only so many problems I can do that make out really nice numbers. The second part of this was talking about theta, which means you had to write a trig expression. And again, the sides of the house, like the sides as the ladder falls, those are both variables. The only thing that's constant is the ladder. So it was worth a point if you wrote me a trig equation relating those 3 sides. You really needed to put the variable in there. Some of you I gave a half a point because you at least attempted to write a trig equation, but if you didn't have the variables correct, then I maybe only gave you a half a point instead of a point. You really could have written sine, cosine, or tangent. I mean, I guess you probably could have written secant, cosecant, or cotangent as well, because we have all sides, we have all the rates, so you really could do any of them that you want. I did sine, so I said sine of theta, the angle between the ladder and the ground, that's right here. So sine would be y over 13. But I just want to say, you could have said cosine equals x over 13 and got the right answer. You could have said tangent. Tangent would have been a crazy one to pick, in my opinion, because you would get both of them are variables. You'd have to do the quotient rule. To me, that's a terrible choice. But sine or cosine is a great choice because we can do the derivative of that. So it was a point to write the correct, a correct equation here. And then it's a point to take the derivative with respect to time. So if I use sine, the derivative of sine is cosine, but then I would say d theta over dt. And then when I take the derivative, we did one just like this, at least one, maybe two. I don't need the quotient rule here, right? The derivative of that is just 1/13th, and the derivative of y is dy over dt, which I found up there in part A. And I just want to show you, you don't have to write all these down. I'm not going to do tangent because I don't want to do the quotient rule. But if you did cosine, you would say negative sine equals 1/13 dx over dt. Like, really, it's the same setup as just different values that you're using. So it was a point to write the right equation. It was a point to take the derivative with respect to time. And then just like the last one, it was a point to plug those values in correctly. We know all sides of the triangle, so you can tell me what the cosine of that angle is now at that moment. At that moment, when x is 12. So the cosine would be 12/13 d theta over dt. And then you have to use the value that you found from part A. If you gave me an answer in part A that somewhat makes sense to the problem, and then you use that wrong answer correctly, you can still get this point even though it was wrong in part A. So if you did everything else right, but maybe you got a different answer up here, and you plug that wrong answer in here, you'll still get all 3 points here. They're not going to take away the point again. So they call that a follow-through point, and they'll read with your work. So just keep that in mind, that if you're like, man, I don't know what my answer is up there, make up an answer up there and then use it down here. But this was negative 12. That's what we got up there. So if I was solving this, I would multiply by the reciprocal. And then it works out very nice because the 13s cancel and the 12s cancel, and you end up with negative 1 radian per second as your answer. And I can solve it with the other ones if you want as well. But I think we really got tripped up on the equations, right? That was the hard part of like knowing what equation to write. And then if you didn't write the right equation, I really couldn't, like, you can't earn any of the other points if you didn't do the right equation. And so that's where it was a lot of not very many points on the FRQ. And I really want to encourage you to retake this. I told you on Friday I'm not going to be here, and I'm going to leave the retake for Unit 3 test. I will also leave the retake for this. So if you want to retake that, that you can do that as well. Okay? And if you have, I have my work for the multiple choice. I just don't want to spend the entire period doing that, but I'll be happy to look at it with you during another time. You're welcome to look at it in homeroom or some other time. Yes? Like if you did this? Yeah, like no matter which way you set it up, we should get the same answer. That's why it's all like, even if you did tangent, you're going to get the same answer. Because if you did negative sine, sine would be, what, 5/13? Using our picture. And then if you look up at what dx over dt was, sorry, I forgot my d theta over dt on this one. Dx over dt was 5. So when you multiply by the reciprocal, the 5 and the 13 are going to cancel out. And so no matter which trig equation you set up, you're going to get negative 1 as your answer. And so that's why sometimes you don't have enough information, like you're like forced into solving for one. But when you know all 3 sides of the triangle and you know both rates, you can do whichever trig equation works best for you. But sine or cosine should be what you pick. Okay? Okay. Let's talk about derivatives now. I think we'll be happier with this stuff. Maybe. I don't know. I'm going to just keep holding this like a game show host, okay?
Was Savannah White?
Vanna White.
Vanna White?
Vanna. It's just Vanna. I didn't do all of this, but I did a few of them. I asked you to finish them to just think about what's happening. And I know the estimation, there were a few of you that were like, I thought it was 4 and you said 3, or the other way around. It's just a guess. What we could do here is just tell me if it's positive or negative, but we were just estimating, so then we could also practice writing a tangent line. But did you have a question on one of these? Do you want me to just kind of go through one? Like, if I did I do -1 in the video?
You didn't do -1 and 1, 3,
Yeah.
5.
So like if I looked at -1 and I drew that tangent line in, I hope what you can see from there is the function is decreasing, which means that the derivative, the slope of the tangent line has to be negative. Now approximating that, we're going to talk about that more second semester when we do something. If you're just in the ballpark, it's okay, right? So like if you like, man, you said 4 and I said 3 in the video, it's close enough. Like that's close enough if we're approximating. If I was doing this, I would say at -1, I don't know, I would probably say -1 or -1/2 if I was approximating that. What do you say? Did anybody? Yeah.
What is, like, what?
I'm approximating the slope of the tangent line at this point. So if I drew a line in here, at that point, I'm trying to say, like, what would the slope of that line be? And when I draw it with that, it kind of looks more like down -2 than -1. But again, if I said the answer was -1 and you gave me an answer somewhere around -1, I would count that correct because it's close enough for you to see what's happening there. We'll get better at that as we learn more things, but don't focus on that part right now. Focus on the fact that it's a negative line because the function is decreasing is what I want you to get from that. And so, like, if you got a negative number here, like, you should get some negative number, like -1 or -2. Look, let me make -1 because those are all lines. If you got a negative number for the derivative, then every time the function's going to be decreasing when you get a negative slope of the tangent line, a negative derivative. If you get a positive estimation of the derivative, every time the function is going to be increasing. And if you got that the slope was 0, like at 1, 2, 3, 4, 5, is that 5? At 5, that's a slope of 0. Those are only going to happen when you have a relative max or a min on your graph. And so really big connections that we can make talking about derivatives and whether my graph is increasing, decreasing, or has a relative max and a relative min. And did I write this out on the next page for you to write all that out? Okay, I didn't think so. That's why I retyped it. These are really big ideas that are how we can solve these problems. And so I highly recommend, I know it's a lot to write, but you write this down, because if you know the value of the derivative at a specific point, I can say if f prime of a is greater than 0, if my derivative is positive, then the graph of the function is increasing at that point. Always. Not sometimes, always, that is a true statement. And if I plug in a number into the derivative and I get a negative number, then the function is decreasing at that point. So I don't need a graph to know that. If I just have a derivative, I can tell if the function is increasing or decreasing. This is in the extra packets I gave you yesterday, Jacob. I handed out 2 extra little packets yesterday. That's where these notes are from. And then relative max and relative min, turning points on my graph. If the derivative equals 0, and I can see that the derivative changed from positive to negative, then I know every time if the derivative changed from positive to negative, then it's changing from increasing to decreasing. Nope, I said that wrong. Hold on, I think I wrote this wrong. If it changes from increasing to decreasing, this should say maximum. So I draw the picture. Because decreasing to increasing, this should say minimum. And I know some of you love tables, hate tables. They like to give us tables for derivative values and ask us, like, how many max and mins does this have? And we're looking for where it's changing sign. Because if it changes sign, we know it had to equal 0 somewhere. And if the derivative equals 0, it's a relative max or a relative min. I about took a drink of my microphone. I just went.
It would have been an ASMR. These are boys.
Always true. And again, this is from the other curriculum that I used to use. This is from Unit 2, and so some of the stuff that I did in the video, like towards the end of like estimating, I hope that you're like, hey, we've kind of done this already, that like we've estimated a derivative using slope, but what we didn't do is talk about the increasing decreasing part, and so that was kind of the extra part that I wanted to throw in here before we jump ahead. Yes, yes. And this is a very, like the multiple choice question I showed you today, it's also definitely a part, it's going to be a FRQ. There'll be somewhere that asks you whether a graph has a max or a min and how do you know, and you're looking at the derivative to do that. Whether it's a really ugly function that we can use the calculator with, or it's a function that we're doing by hand, and we're going to practice that a lot kind of the rest of the semester. Did I leave some of these at the bottom also to do, or did I did them all?
You did 0.
I asked you to do it, yeah.
Oh,
So I'm probably just going to do like one more of these.
I just don't know how to do the tangent line.
Oh, yes, yes.
I can do the tangent line if I can just find out the estimation of the derivative.
So on the front page when we were estimating the derivative, we had to draw that line in, and it was definitely a rough estimate. But when they give me a table of values and they ask me to estimate the derivative, remember that we can estimate the slope of the tangent line by using the slope of the secant line. We've done that. So if I have a graph and I want to find the tangent line, I can use 2 points near that to find the secant line, and they're not exact, but it's a close approximation. And so that's more likely something they're going to ask you to do on the AP test than like sketching on a graph, because that is like a rough estimate. And so if I want to find the slope at 1, if the slope at 1, this is the x value of 1, my advice is that we use the 2 points next to that. So I would use 0 and 4, or we could use 0 and 1 and 1 and 4. All of those would be correct things to do. So what did I do for the 0 one? Did I use -3 and 1, or did I use 0 in it? Yeah, so I always use the points around it, but I will tell you there have been AP tests where they give you, like they would say as long as you could use 0 and 1, 1 and 4, or 0 and 4. All of those are going to be approximations, but they're going to be close enough that we could do that. And so if I use 0 and 4, I'm just going to find the slope. Estimation of the derivative is like average rate of change versus instantaneous rate of change. So we're going to use like f of 4 minus f of 0 over 4 minus 0. Yes, yes. And so again, average rate of change versus instantaneous rate of change. Slope of the secant line versus slope of the tangent line. But we can approximate using that. So I can take those values and say the values are 0 minus 1 over 4 minus 0, and I get -1/4. You with me on that?
I got freaked out because I did it the other way and I did 1 minus 0 over 0 minus 4.
But you get the same answer. As long as you go in the same direction, it doesn't matter which way you start. As long as you're consistent in the numerator and the denominator. So right away, when I find the approximation of the derivative at that point, because that's a negative value, I know the function's decreasing at that point. Now the equation of the tangent line. Remember, tangent line equation, that's y minus y1 equals m times x minus x1. M is my slope. X1 and y1 is my point. So the point is the point at 1, which is off my graph. So the point is 1, -3, and the slope is approximately -1/4. So my tangent line would be y minus -3 equals -1/4 times x minus 1. Does that answer the questions on both the derivative side and the tangent line side? Okay. I want to do other stuff, so I'm skipping the rest of this, okay? Because I want to talk about more about the graphs. I'm really trying through today and tomorrow to get you some information, so then I'm not going to be here Friday and Monday. Friday I'm going to let you retake some stuff, but I'm also going to give you some problems to work on that hopefully you can use these notes to help. And that's where the video ended, right? Like I haven't done any of this. True? Okay, so now it says the graph of a function g of x is pictured at the right. Identify the following characteristics about the graph of the derivative g prime of x and give a reason for your answer. Give a reason for your answer is like what you would write on an FRQ when they ask these same questions. So if this is the graph of g of x, if I want to know where the derivative is less than 0, what am I looking for on this graph? The derivative is less than 0 when g of x is blank. Go back and look. Which one? What did it say when g of x is less than 0? G prime of x, I mean. G prime of x.
G of x is decreasing at x equals a.
Yeah, so like this is kind of true both ways. So this one says if f prime of a is less than 0, then f of x is decreasing. But the other way is also true. So that means if f of x is decreasing, then the derivative is less than 0. Like that's the connection that we want to make. And I know I heard you guys talking about yesterday in geometry. Like you remember, I don't forget what your example was of like if a cat has stripes, then it is a tiger. And so it's like, is the other way true? If it has stripes, then it is a cat or whatever, right? Like the if-then stuff. That we do in geometry for things like this, because if-then means if this is true, then this is true. And if the other way is true, we can say like if and only if. Do you remember that? Like if you say, if a squared plus b squared equals c squared, then the triangle is a right triangle. That's a true statement. But you can also say the other way is true. If a triangle is a right triangle, then a squared plus b squared equals c squared. If it's true both ways, we call that an if and only if statement. And so this is one of those statements. We could say f prime of a is less than 0 if and only if f of x is decreasing. So just know both ways are true. So before I even give the answer to this, I'm going to give the reason. The intervals where g prime of x is less than 0, I'm going to say g prime of x is less than 0 when g of x is decreasing. That is your reasoning. If they ask you to give a reason or justify your answer, that is the reason. Now you have to look at this graph and tell me where is it decreasing. Decreasing would be like if you were walking along it and you were going down, right? So this would be increasing, this would be decreasing. Do you agree with that statement? And then if I'm going back up, that's increasing, but then this would be decreasing. So when we give decreasing intervals, we're going to use like bracket parenthesis stuff. We're going to use infinity, negative infinity. So they tell us that this is -4. We can see that that's -2. So do you agree that that's -4 to -2? Like the x intervals. Let's have a talk about intervals for a minute. I will tell you on the AP exam, they always use brackets. You can have a big discussion about if brackets or parentheses are correct. Brackets are technically the correct way to do it. The AP exam will never give you an answer where one is a bracket and one is a parenthesis and make you choose between it. On an FRQ, if you put parenthesis -4, -2, you would still get the right answer because they're not going to grade it. But just know I'm going to continue to use brackets because I know that's how the AP, like the multiple choice will always have brackets. So we're just going to use brackets because it can still be decreasing at -4 even though it equals -4. Like it feels like it shouldn't be a bracket, but it is, okay? And then this one, the y value or the x value is 1, but it goes forever. So we would say bracket 1 to infinity. You with me on that? And like normally we put like that little u in between. If you don't put the u in between, they don't care. Because we're talking about x values, not y values. So even though this is going down forever, it's the x's are getting bigger. Does that make sense what I'm saying? So it's about the x values, not the y values. So whenever we're giving intervals, we're always giving intervals on the x-axis. We have kind of done this before. We just haven't talked about it with derivatives. So the intervals where the derivative is greater than 0. Again, I can say the statement, g prime of x is greater than 0 when g of x is increasing. Yes, because it says give a reason for your answers. And so we're practicing for FRQ life right now. And it should be everywhere that it's not decreasing, it's going to be increasing unless there was like a constant value on that. But it's just the other ones, right? So that one's going to be from negative infinity to -4. I said it's always brackets, except for infinities, right? Infinity never has a bracket. It always has a parenthesis. And then this would be x values from -2 to 1. With me on that? So intervals of increasing and decreasing. And now look at the last one. It says the values of x where the derivative equals 0. What points on my graph are where the derivative equals 0? Where there is a relative max or a relative min. And so we can look on here where there be a horizontal tangent line. Right here, and right here. It is not a coincidence that that's where the decreasing and increasing changes signs, because that's the definition of a relative max or a relative min. It's where this changes from increasing to decreasing or decreasing to increasing. So I can say relative, well, actually I'm going to say x equals -4, -2, and 1 because g of x has a relative max or min at those values. You could be extra wordy and say that's where g of x changes from increasing to decreasing or decreasing to increasing, but that is the definition of a relative max or min, so you can say that too. This is true for every graph, okay? So making sure that we know negative derivative, the function is decreasing. Positive derivative, the function is increasing. Zero derivative, max or min. So now underneath here they talk about the normal line. We've talked about normal lines already. Like it's, do you remember normal line? It's the reciprocal of a tangent line. So it's the opposite reciprocal slope. Normal lines don't really show up that much. We've already talked about them, so we're not going to do that part either, okay? So I'm just going to put a little X right here. Okay. What's on the next page?
Nothing.
Nothing.
Yeah.
All right. I have a video for this, but I think it's better. We're just doing it in person, and then you won't have a video for homework, right? That'll be a good thing. So now here's where things get confusing. You have to be really careful what they give you, because look at this one. It says the graph of the derivative is given below. The graph of the derivative, h prime of x, of some function h of x is given below. Identify the following characteristics and then give a reason for your responses. So this is where anytime I see a graph on a test, whether it's my test or an AP test, the first thing I'm going to do is I'm going to label what it is. Is it the function or is it derivative? Because it's very easy to look at it the wrong way and then get all the answers wrong. So now this is the derivative, and it wants to know where is the function increasing. So again, before I look at the answer for the graph, let's talk about what's true. H of x is going to be increasing when h prime of x is greater than 0, because it's increasing. Increasing is positive. Decreasing is negative.
When h prime
So
is
h of x is increasing. I'm just going to say when h prime of x is greater than 0. Yes? So on my graph up here, if this is h prime of x, where am I looking if I want to know when it's greater than 0? Where it's positive, not where it's increasing, where it's positive. So where is it above the x-axis? And it is above the x-axis from here to here and from there up. Do you agree with me on that? So that's why I always say think about the reason first and then go look at the graph. So now I can say -2 to 1 and 3 to infinity. If this was a multiple choice question, I guarantee they would also have the intervals where this graph is increasing, because they know that people are going to look at that. They're going to say, oh, it's increasing when it's increasing, like not when it's positive. And so if they give me the derivative and I'm looking for where h of x is decreasing, I can say h of x is decreasing when h prime of x is less than 0 or negative or below the x-axis, right? All of those things mean the same thing. And again, unless you have some part of your graph that's completely flat, your intervals of increasing and decreasing should be the entire graph by the time you do that together. I should have done a different color. So if I go up here, it is below the x-axis everywhere else. So negative infinity up to that point, and then in between those values. So that could be, oh, I about did it wrong. Parenthesis, negative infinity to -2, union 1 to 3. To 3. With me on that? All right, what about the next one? It says the values of x where the function, where h of x has a relative max. Not the derivative, this is the graph of the derivative. So remember, what happens to my derivative when my function has a relative max or min? My derivative equals what? The derivative equals 0, but then we have to be really careful because they're asking us to tell the difference between this. So we're looking for where h prime of x equals 0. Nope, yeah. And where h prime of x changes from, if I want a maximum, I always draw the picture, it helps me. A maximum looks like this, so the function's changing from increasing to decreasing, so the derivative's changing from positive to negative. And then without shouting it out, I want you to go up there and look at that graph and see if you can tell me, does this graph have any maximum values where the derivative equals 0 and its values are changing from positive to negative? Do you think that it has 1, 2, or 3 maximum values?
Wait, are we looking for the x value? We're looking for x.
Yeah.
1.
Well, this is the derivative, but I'm looking for the x value where it has a max or a maximum. So I'm looking for where the derivative equals 0, and there are 3 places where this derivative equals 0. Do you agree with me on that? But to be a maximum, it has to change from positive values to negative values, which means the derivative has to go from above the x-axis to below the x-axis. So that is only this one, because these are positive x values, these are negative x values, which means the function is changing from increasing to decreasing. What are these 2 values going to be? Which means they're going to be minimum values. Well, if you were looking at this graph, the minimum and the maximum would be these points. But that is not the minimum and the maximum of h of x, which is what we're trying to do. We're trying to go from h prime and answer questions about h. So the only place where that is true for the maximum is at this value right here. So zeros on your derivative are max and mins on the original function. So I can say that's only at x equals 1 on this problem. And where would the original function have a relative minimum? I can already know it's these two, but I'm going to say it's where h prime of x equals 0 and h prime of x changes from negative to positive. And that's because if h prime of x is changing from negative to positive, that means h of x is changing from decreasing to increasing, which is going to give me a minimum every time. So we can say x equals negative 2 and x equals 3. You can see how this is a very easily missed question on a multiple choice question, because they might ask just for the maximum and they'll give you all 3 zeros. It's really easy to pick that. They'll definitely just give you the maximum of the derivative because people pick that too. But we're going to keep practicing this. So just know this is like day 1 of this. We'll do one of these. We'll see. Okay, are we ready to go on or you're still writing? All right, so now look at the next one. It says if h of negative 1 equals 1/2, what is the equation of the tangent line drawn to h of x at that value x equals negative 1? What do I need to write a tangent line? A slope and a point. What did they give me in this problem? They gave me, is this the slope or is this the point? That's the point, right? It's not h prime. So they gave me the point, but I need to find what h prime of negative 1 is. So on my graph, if this is the graph of h prime, do I know what h prime of negative 1 is? Because it's just the point on that graph, because this is the graph of the derivative. So h prime of negative 1 is just whatever point that is on the graph. So since they didn't give us h of x, they had to give us the point, and then we could go up and read the graph to find the slope. So my slope is 5. So now I can write my equation. So y minus 1/2 equals 5 times x plus 1. And since the slope is 5, I know it's above the x-axis, it's positive, my function is increasing at that point. And I don't even care about the next one. Whew, that was a big day. It's a big day of calculus. If you turn the page, there is some problems we're going to work on tomorrow. But what I want you to do, maybe even before you leave here today, is I want you to do 2 through 6 only. Like that's kind of your homework for tonight. And they give you a graph, and they ask you to just label some things on that graph about f of x. So notice this is the graph of f of x, and they're asking you a bunch of questions about the derivative. There is more than one right answer, but we'll talk about that tomorrow, as long as it's in the right area. And then it says give a reason. So I really want you to practice that, like because the function is increasing, or because the graph has a max or min. I want you to start thinking about how you're going to give justifications to those problems. So that's your only homework, other than test corrections maybe you need to work on, other than looking over that quiz. But no new video for tonight. Tomorrow we will work on this some more and go from there. Okay? I think that's the plan.
I like that.
Okay.